Okay, perfect. Thanks, Kellan. So, welcome to Inference Gateway Community Meeting. Today is February 5th. So, welcome. This is a CNCF project. So, please follow the guidelines, be kind, be nice. And with that, we can get started. So, let me just open the agenda and share it with you. Share screen. Oh, man. I might need to disconnect and then come back. Not sure yet.
Technical difficulties from an engineer. Come on, man.
Yeah,
No, I'm just
let
kidding.
me give me one moment.
Do you want me to run it? I can run it.
Yeah. Go ahead,
Yeah,
please.
no
Sorry for that.
problem. No, it's all good. We'll just trade. That's fine.
Okay. Okay.
For those who don't know, why don't you tell him? Can you tell him now or no? Maybe I spoiled it. He's already gone. But Near had to get a new laptop. He'll give you more details as to why. Um, Spoilers. I think I'm sharing the right thing. I sure am. Cool. So review AIs. We have created an issue to track the nightly benchmark. I know Abdullah is on top of this. Uh, I saw some messages internally about this, so we are working on it. As far as I know, and we'll take a look at the nightly right now. I think the data is not propagating, so we probably won't see anything. No issue. Working on it. Apologies. Um, Okay, we do see some things, but I thought it was delayed. Maybe it's been propagated and fixed, but if so, great. I see expected numbers here, so we will move on from this. I know we did we call it lawn mowing, where we did some grooming of the backlog. We're trying to just chip away at that to make our backlog a little more manageable. Understood that it has felt overgrown. If people have felt that, I definitely have. Um, Cool. So jumping right into the agenda, just Luke and I wanted to shout this out. This document here kind of proposes some uh, semi-significant changes to flow control. It's all very additive. So flow control isn't going to necessarily be readapted, but it will be expanded. That's the word I'm looking for. Uh, so open to discussion. Yeah, Nir, go ahead.
Yeah. I left a few comments there on the doc. So
Mhm.
basically, I think the general idea and general direction is excellent, and I agree. Maybe you can, for those in the call who haven't seen, maybe you can do like a brief overview on the proposal just for the context. But so I'll let
Yeah.
you present and then I'll add my comments.
Sure, sure. So to kind of just give a 10,000 foot view, flow control, we see it as a defensive system. It uh, basically sits in front of the pool and makes sure that we protect your accelerators and your accelerators are performing in the way that you want. Uh, so what that means is we kind of need to adjust the granularity of our saturation detection. It was a gate. Luke would call it a bang bang controller. Um, and that was making for odd behavior. So we're changing the saturation detection. This is the first step of three of this proposal to be more granular so that we can give more information to flow control so that it can actually rate throttle rather than just a binary open or closed gate. So that's step one. Um, Step two is the priority based holdback. And this one has the most contention, and we can deal. I'm happy to have that discussion after I kind of give my spiel. But the idea is that we can't predict the future, and we know that there will be a lot of users that have a pool that have low priority requests and high priority requests. Well, low priority requests we expect to be in more volume. That's kind of the general assumption. That doesn't even have to be the case, but But just for our thought experiment, low priority requests have higher volume. And so they could fill up the pool if you let it, hold back reserves capacity for your high priority requests to ensure that you will always have capacity. Um, and then I've also introduced eviction because you still have that problem of not knowing the future exactly. So if you set these holdback levels, you could still have stranded capacity that could be used if high priority traffic never comes in. So eviction would allow us to consume the entirety of the pool and then claw it back. So those are kind of the three main concepts. There's some nuance here. There's some future work. I see some hands. So I'll stop talking. Abdullah and then Luke.
Maxime, I don't mean to put you on the spot, but I know that I want to hear your thoughts on eviction. Does Dynamo support that, Dynamo router? Is this something that you folks like, have a heuristic for, like when to do eviction? Do you see value in it?
I think we're thinking about it, but I don't think it's in the Dynamo. It's implemented already in Dynamo router.
Okay.
I might be wrong, but that's the best to my knowledge. Probably we still need to get this same problem solved in the future. We still need to introduce this priority based routing. I don't think we have the notion of priority in Dynamo, which is separate from Inference Gateway. I mean, we are thinking exactly about the same set of problems right now.
Okay.
Yeah,
I just wanted to tap on your knowledge, like if you tested this before, eviction in general, how it behaves. Thanks.
Yeah, just to add, that's the same signal I got from Anish that we're looking at the same problems and they're very much on board with this direction. But cool, good call out, Abdullah. Luke, go ahead.
Yeah, I think looking through the doc, there's like three main areas of like feedback or contention. One is on the config surface for holdback, like how do users define that? I think that's more of like a tractable problem to be solved. The other I think is like on the concept of saturation. So I wanted to go over like what my view is on saturation conceptually, because I think there's like two different mindsets here that like informs a lot of the opinions going on in the doc. So like in one sense, you can view saturation as like the hardware capacity limitations of the pool, and saturation is just a capacity gauge, like how much of the pool's capacity has been used up. In another sense, you can view the flow control layer generally, in addition to the priority and fairness and multi-tenancy feature set, as giving the operators of a pool the ability to control the latency throughput trade-off of traffic serving. So the way that I've kind of been viewing saturation conceptually, because this is basically a throttling layer between EPP and the backends, is the mechanism by which operators control that trade-off. Basically, their request latency versus throughput. So I view it more as like a soft scheduling cap or a soft limit that operators can configure. So if you know that, like through benchmarking, for example, your pool can accommodate like 150 concurrent requests before you start having latency degradation, that would become your saturation target value, right? And so when I converted saturation to a gauge, the idea would be that 1.0 or full would be when the pool is operating at that target set point. And then basically room below or room above shows you how much you're under or over that latency throughput target, rather than like the degree to which the actual physical resources of the pool are filled by requests. And that also kind of aligns with making saturation detection pluggable, because it allows you to change like the semantics of what that fullness definition is. Right now we have like the metric heuristics one, we have the concurrent requests one, etc. So that's kind of the angle that I was approaching that from. But I know there's also different like views of the signal itself and what the semantics of that are.
So I think that's an interesting point. It sounds like you're viewing the one value, the normalized value, as a configurable idea. I think that those two ideas are congruent. I think they can work together, viewing it as an entire pool versus what you're targeting. Because to me, you're just shifting the scale. To me, if I'm looking at it, because I do see it as a total capacity of the pool. To me, if one is like literally you cannot queue a request on any of these, you're then basically you could just transform or mask your values. So if you have a latency target, that would be like, I'm just going to spitball a number that has no basis in reality. 65% of the total pool saturation, we could shift that where that becomes your one, and then full saturation of like literally you cannot send any more requests is whatever. I think both of those are totally acceptable, and I think you make a great point that makes it pluggable, and a user can decide if they want to switch to that. I think that's fair. Um, but anyways, Nir, why don't you go ahead, unless Luke, you had.
Yeah. So there are a few points. Actually, Luke touched most of them, the points that I wanted to raise. So yeah, that the UX of setting the limits is like, I can't think of a reasonable way to decide on the numbers. At least not in the current proposal, but I do think it is like doable, but not with its current proposal. And then about the signal, which I understand the thinking behind it, but I was more thinking about the signal as like the percentage of the saturation of the whole pool. And that would be like a number between 0 and 1, where 0 is completely idle and 1 is completely saturated. And also when I looked at the code, and maybe I missed something, all the places that are using the saturation or reading it, they are just checking if the value is greater than 1, greater or equal to 1. So there is no use of the how much are we overloaded above threshold, at least not for now. Plus, I'm thinking that if we want to signal like metrics that are usable for auto-scaling, then the pool saturation would be the one, right? I'm thinking like if the pool is saturated like 80%, then we trigger auto-scaling or something like that, same as we do like with HPA. And there is additional concept that I don't know why I haven't, why I didn't write it in the document as a comment, but what is also missing for me is the time element. So if a workload is waiting in the queue a lot of time, I'm expecting the priority of that workload to slowly become higher. Like if a low prio is waiting in the queue, I don't know, for an hour, then it should sometime become medium, right? It's not the same as the same low prio workload that just came in before a minute. So we had this kind of a problem when I worked in Watson in IBM, and they had this Watson X queuing, and there was like a time that if a workload spent in some priority queue for a while, they just switched to a higher priority in the queue. So that's just another point to consider. Maybe it would be useful to do it here as well.
With regards to the capping the gauge at 1, you're right. Even with the holdback proposal, right, you'd be throttling when it's any value less than or equal to 1 at all points. So the only reason it could conceivably go over 1 in practice is the fact that our dispatch unit is in terms of requests. And our signal, depending on the saturation detection implementation, is in terms of metrics or tokens, or in-flight requests would be consistent. But there's a chance that the dispatch actuation doesn't correspond to the signal, like the feedback that we get. But that should be relatively bounded and not really burst past 1, like conceivably. So I think capping that is fine. with respect to priority, like flow control has two different classifications. We have the actual priority level from the inference objective, which is like for your overall workload class. And then you have pluggable like ordering policies for the queues themselves. So each flow, which is like the inference objective priority and then some grouping identifier, has its own priority queue. And you can change the logic of that queue, like the sorting logic, to be basically what you're describing. So basically, you could write like a deadline based policy where requests are dispatched by how urgent their deadline is. But that's always going to be operating in that second class of priority. Like with you're never going to be mixing or promoting a request from a priority queue to a different priority queue. You can only move it up the slots in the queue it is already belonging into. So I don't know if that fully addresses what you're describing. But I'm not sure.
I think it does. Yeah.
Okay. And then
yeah.
Oh, go ahead.
Yeah. So two more points that I want to raise. So one point, so you mentioned the fact that different plugins of the saturation might include different semantics, right? Something
yes.
like that. Yeah. So I think it doesn't make much sense. So I want, like in the semantics, what is the meaning of this signal? I want the meaning to be always the same. So this is like a component of the system that should mean something. And that, what does it mean, should be like as any other plugin, right? Scorer, it's meaning that it gives a score to all the candidate endpoints. And saturation should mean something that is consistent across different implementations of the saturation detection. So it could be that we have different implementations. Each of them might be optimized for different use cases, but I want the semantics, the meaning of it, to be the same. So this is one comment. Not sure if you agree, but this is at least what I'm thinking. And the last comment, so as of today, the saturation detection is like, it is in the request path. So we calculate saturation for each and every incoming request. And I believe for most of the requests and most of the users we have today, the requests are actually using all the endpoints in the pool. So as far as I know, most of the users, they do not use this subset filtering, which is the only case where we filter endpoints for the saturation detection. So my thinking is that I would like to consider maybe moving saturation away from the request path and doing it asynchronously from the requests. And like, if I have a burst of, I don't know, 1,000 requests in 50 millisec, and our scraping interval, the metrics, is 50 millisec, then I'm not going to collect metrics in this time window. There is no point in calculating the saturation 1,000 times. So I think the saturation detection should run asynchronously from the requests using the same scraping interval, whatever interval it is, and then have some saturation signal for that time window until the next time we collect metrics. And then on the request path, we can only, query what is the saturation signal and not need to calculate it on every incoming request. But that's like an optimization.
I agree with that. The only reason it's on the request path is the candidate pods for the endpoint subsetting.
Yeah.
As soon as that's not needed, or if that's not required, and we treat saturation as true pool aggregate fullness signal, that's the semantic. Is like how full is the pool with respect to your objectives on the latency throughput trade-off. We should be throttling requests. The only time that the per request semantics matter is if there's like distinct subsets of endpoints that requests are being routed to.
Yeah.
I agree it should be async. The concurrency based version, like the in-flight requests version of saturation detection, uses the request lifecycle hooks to maintain an internal counter. So it's not actually scraping in that regard. But for the old one, the utilization metrics based one, then yeah, I agree for sure. The only other thing I wanted to bring up is there's a comment in the doc regarding like defining the way we calculate the saturation gauge is based on operator config. I don't know if we have time to like go into that on the call, but I think that's also important to think about with respect to the semantics for saturation. The way I was viewing you would set this for concurrency, for example, is you would run like a benchmark or profiling workload on your pool, and you would see like this is the amount of requests I can accommodate before my latency objectives start being violated, kind of per pod basis. And then you would configure that, and it would be like a stable watermark for running your actual production workloads. So in that sense, like the operator config is authoritative. I think there is some value in maybe dynamically finding what the ideal concurrency is based on like latency targets or other things. But I was trying to keep it relatively simple to start, which requires some upfront knowledge. But I don't think that's any harder to tune than the queue depth and KV cache utilization thresholds that we have with the existing config as well. But that's always going to be a tricky aspect of the saturation detector.
So, if I may, I'm trying to talk about the subsetting thing in other channels. To bring it here and to address the question in chat, subsetting makes, to me, flow control near impossible. I used a terrible analogy when talking to someone yesterday, but I, say, assume you have 10 bank accounts, model servers, right? And you have bills coming in, and you know how much money you have in each account. And I ask you, can you pay this bill? Can you pay this bill? Can you pay this bill? You could probably figure that out, right? And assume you continue to make money, fill your accounts. But if I then said, here's a bill, but it requires a subset of your bank account, and I'm not going to tell you which ones, and each bill can have a different subset, you then start to lose your ability to give information on, can you fill this request of payment? Again, terrible analogy, but I tried to take it away from all these abstracts. But I think subsetting and flow control are incongruent, at least the way it currently sits. If subsetting is a per request thing, I think they're incongruent. I would like to see that much better much more well fleshed out. So that's one part. The other part on saturation detection, I would lean towards the one being hard saturation, just because that's objective, and then you can look at that across pools and you can reason about it. I wanted to take a little bit of time to kind of talk about holdback and maybe the configuration. I agree that we should iterate on the UX of configuration, but the usage limit doesn't necessarily correlate to a direct number. Like this 60 isn't 60 requests. It's 60% of the pool. It is normalized just like the saturation detection would be normalized. It was a first stab. It really needs user feedback, because this is one of those, how does it feel to use things? So I would love to see that fleshed out. But I think the point is we need to make it normalized so that it could apply to any different implementation of saturation detection, the pool, etc. Abdullah, go ahead.
My only I generally like the idea of holdback. I mean, my only problem with it is that it is going to be impractical to apply without the request eviction. I don't believe that any user or customer is going to do a holdback unless they know that they have the other flows will always be present to use all the capacity and ensure high utilization. So my only worry with the holdback is handling underutilization. I know you have the proposal for request eviction, but if that request eviction, I don't know if we can just kick the can on it, basically. I mean, you can always implement the holdback, but I don't know if anybody's gonna dare to use it and have their extremely expensive pool underutilized.
Yeah, I generally agree with you. I know we have one customer willing to try it with just holdback while we figure out exactly how we make eviction work. Also, did want to mention that Luke made a great point about the profiling of each model server flavor. That was something Anish slash Dynamo also mentioned. I'd be really interested to and see how, as we implement this into flow control and it starts to be able to communicate and express and control the pool, how that interacts with a multi-pool environment and through Planner or WVA. I'm hoping that those two actually come together. That's something Anish and I are discussing, and I hope to have plans soon. But I think this creates a really compelling, full-on mass story that will be really useful. And I'm excited about it, and I do agree that there's open questions. Holdback, I personally wouldn't use holdback without eviction. I hate the idea of just letting capacity sit there. But if a customer, while we're figuring out eviction, if a customer's like, look, I just need to keep a little thin slice of capacity, should high priority requests come in, even though they're sparse, they still want to handle them. Um, that's an idea. But anyways, any other feedback? I've talked a lot. Cool. Thank you all for your thoughts. I agree that there are many open questions, and hopefully this ends up being a really compelling feature in our suite. Luke, go ahead.
We can kind of breeze past this. There's a issue that was open for like making the metric score generic. So using like the pluggable data layer to define like a data source and then wiring that into the metric score. I'm mainly just looking at some feedback on making sure that the plumbing and the config wiring of all these things is like sensible and not like overly challenging for users. I think functionally it will work. But yeah, this would allow us to take any Prometheus metric from backends in the pool, and then you define your score around it.
Very cool. Itai, do you mind taking a look? I'll take a pass through as well, but I'd love to get Itai's feedback. I see he's in the call. Cool. So then we'll move on to Yang. Yang, do you want to give us a little lowdown on this?
Yeah, sure. So, I directly put the proposal into a PR, so it looks like I should put it in a Google Doc, right? That's a correct way to do it.
Yeah, you're good. However you want to do it, but I need to remember how the heck there is a way to do this. Okay, that works.
Yeah, so this proposal is to upstream prefill decode from the like LLMD's inference scheduler to IGW. So there is right now I wrote the request flow into this proposal and also this goals and non-goals. So like right now I think primarily there are several things. First, we want to formalize how the header looks like, and possibly in the future be able to used by other frameworks. And the second thing is the one that I think there's a big discussion there on how to handle the profile name. Because like it's not only used during the for the plugin to decide where to send the request, but also since PD it's a sequential step, it need to decide decode node first and then prefill node second. That's how LLMD does it right now, but I'm not sure in the future if there's any framework which may want to decide like in the reverse order, where it decide prefill first and then decode later and then send the request to prefill. So I went through the discussion like on the LLMD like Slack channel, I think lastly, we might want to go with a helper function to handle that like a profile result in the scheduling result part. Yeah, that's this part. And also I think the third thing is how much of the plugin we want to upstream from like LLMD's inference scheduler to IGW. So in this proposal, I just put all the necessary pieces, which means we need to upstream a profile handler, which can sequentially handle the prefill and decode. And also we will upstream the header injection part where we just inject the like metadata from the header. And yeah, and also I think if this is like during the implementation phase, we may need to go over the existing plugins because as before we see for the prefix plugin, it needs to be updated for PD. So we may need to go over other plugins inside IGW to see, to examine if any change need to be done there.
Cool. Thank you. I think this is important to get aligned on. Any thoughts here? I see a hand near.
Yeah, actually, it's a question rather than a thought. So I'm thinking about the EPD use case. So EPD is right across the corner. Maybe even Dynamo already has support. So Maxim, do you have support already for EPD in Dynamo?
Yeah, we do.
Okay. Yeah. So if we already go into like standardizing protocol, maybe we should give it a thought of how to standardize also like the support for EPD.
Sorry, what does the E mean here? Expert or
embedding?
Embedding. Oh, embedding. So which means embedding is also disaggregated into its own like computer resources, right?
Yep.
Okay. Then is embedding also part of the, how to say?
I think the point here, can we make it a little bit more generic, not just prefill decode, but we can extend it to more, workers in the inference plan.
Like multi-stage,
Right.
something along these lines rather than a fixed set of profiles, because that would generalize the concept. And as we all know, in the AI world, things come and go very fast. And today we have PD, tomorrow EPD, and the day after we might have, I don't know, XEPD or something like that. So we need to somehow make it more generalized in a way that we can adapt to changes quickly.
So that means we may not even want the fixed metadata, right, or fixed name of each component or profile, because to them it might be embedding. The next day there may be another thing come up.
Tokenization. Yeah. Abdullah has a hand though.
So if we implement this as a plugin, I mean, we have all the flexibility to re-implement this using another plugin that supports embedding. So I don't know if we really want to hold until we find a solution for embedding, like EPD, if this proposal is encapsulated in a plugin that we can evolve into another plugin, for example, or add another plugin that implements and adds support for EPD. At least that's my thought. Like, I mean, we do have that luxury, I guess, because we can always remove that plugin and replace it with something else.
E-time?
I think We should understand also. I mean, first, I'm for finalizing the PD protocol if we can now. I think that makes sense. Not hold off until we have a defined EPD, especially because I think some model servers might implement EPD under the covers, so they might not even need clear separation. I looked a little bit at the VLLM implementation, and they are suggesting an internal embedding or encoding cache to do the transfers. So it's not even clear how this would be done there. So I do wonder if EPD is not going to be model server specific, I guess is what I'm trying to say, Neil.
Yeah, I'm not sure myself, because I haven't tried, playing myself with EPD. I'm familiar with PD, with EPD not yet. That is why maybe Maxim, maybe you have more insights on this.
I think long term we want to be able to optimize the whole inference graph by disaggregating different parts, including embeddings. We don't know yet the benefits of doing that. I mean, if you collocate embedding to either profile code, it might be more or less the same performance. But I think moving forward, having that flexibility to be able to, scale up and down the different parts of inference graph would make a lot of sense to me. So I don't know.
Yeah. So thoughts here. I would, if Maxim, if you're okay, we would love to lean on your expertise. So my thoughts are, if we aren't, painting ourselves in a corner with this proposal, which I don't think we are, I say we move forward. But then would love to, Yang, if you're open, you and Maxim can work together, and we can find something that is potentially more future, more general proof, more future proof, more general. Does that sound good?
Yep. Let's move this conversation to Slack, and I'll text some people who are focusing in Dynamo on the ZPD stuff, and we can maybe confirm, what's the plan. Mm-hmm.
Okay, sure.
Cool.
Maximum, I will reach to you. Yeah.
Cool. That sounds great. Thank you, everyone. That's the agenda. I think this has been a great conversation. I might see new names. I won't put anybody on the spot, but if anyone wants to say hello, as per usual, please do. We'll just give a moment. Cool. Okay. Thank you, everyone. Again, very productive. I'm pretty excited about what we got going on this year. See you next week.
Thank you. Bye.